Again, the oxidizing agent is a chemical species that contains the element that is itself reduced. The reducing agent is the chemical species that contains the element that is oxidized. They work together. One can never be without the other. Oxidation has to happen with reduction because it's an electron transfer. Here are some common oxidizing and reducing agents. You can pause the video at this point. I would jot these down somewhere handy so that you can recognize them because they show up in reactions all the time. Some common oxidizing agents that you should know for sure. Permanganate, MnO4- in an acidic solution will turn to Mn+2, but in a basic solution will turn into MnO2 with no charge. Dichromate, Cr2O7 2- will turn into chromium-3, and that's usually an acid solution. Dichromate doesn't exist in a basic solution. It turns to chromate. We'll take a look at that in a lab later. Nitrate, if it's 6 molar, which is roughly a third of full concentration, 30% or so, then it will turn into NO, nitrogen monoxide. If it's concentrated NO3- from HNO3 from nitric acid, then it turns into NO2, which is a brownish gas. Sulfate becomes SO2 or H2SO3, but you remember that H2SO3 is an unstable acid and it dissociates back into water and SO2 anyway. So sulfate turns into sulfur dioxide, or in water it can dissolve a little bit to become sulfurous acid. Hydrogen peroxide, H2O2, will turn into H2O when it acts as an oxidizing agent when it's reduced. X2, X stands for halogens, any halogen, because they're all diatomic, right? F2Cl2Br2 and I2, so X is any one of those. That can also act as an oxidizing agent. It is then reduced to the halide ion, X-. M is any metal, so metal ions with positive charges can oxidize other things and be reduced to the solid metal, the free metal. Some reducing agents, peroxide again. Peroxide can act as both an oxidizing and a reducing agent. When it's a reducing agent, it is itself oxidized to oxygen, molecular oxygen. And so the oxygen in H2O2 in this case is going from a -1, because it's a peroxide, up to 0. So it's increasing, it's being oxidized. But it's going to cause something else to be reduced. Halide ions go to halogens, metals go to metal ions. Those are reducing agents. Oxalate, C2O42-, becomes carbon dioxide, usually in acidic solution. So you'll see bubbles. Sulfite, SO3 2-, or sulfur dioxide, will become sulfate when they are oxidized, causing the reduction of something else. And NO2-, that's the nitrite ion, will become nitrate when it acts as a reducing agent. And nitrite specifically is a dangerous one. You don't want to get that in your body because it is a reducing agent. It is itself oxidized to nitrate. And nitrites are sometimes salts containing nitrite are used as preservatives in hot dogs or lunch meats. And they can cause some serious problems when they get into your body. They are generally thought to be carcinogenic. Part of it is their reducing ability. So just a primer on oxidation reduction reactions, and make sure that you watch the half reaction video so that you can remember how to balance half reactions.